When we're adding in octal or hexadecimal systems, it's exactly the same as though we were adding in decimal. So let's have a look at what happens when we're adding in base 10. I know you know how to add in base 10, but let's investigate each step. And if we can explain why we do what we do working in base 10, we can easily translate that to adding in octal or hexadecimal. It's the first thing that we do. If we're adding by hand, we're going to line up our two numbers, in this case 436 and 1724, so that all the place values add up. The thousands, the hundreds, the tens, and the ones. So we'll write 436 over top of 1724, making sure that the ones, the tens, the hundreds, and the thousands add up. And then we start adding on the right-hand side. So these are both numbers in decimal. 6 plus 4 is 10. But in base 10, in decimal, we can't go past 9. If we do go past 9, we have to carry a 1. So what we do is we subtract the base, which leaves us with 0 in the ones, and carry the 1 into the tens place. That's where our 10 has ended up. Now adding in the tens, we have 1 plus 3 plus 2. Well, that's just 6. Since 6 is less than 10, we're allowed to keep a 6 in the tens place. In the hundreds, 4 plus 7 is 11. Again, we can't go past 9. And maybe you know what you're allowed to indicate here, but formally we'll say, well, anything 10 or greater is going to have to be carried to the next line. So I'm going to be left with 1 in the hundreds place and carry the 1 to the thousands. Adding the thousands, 1 plus 1 is 2. We're going to use exactly the same strategy with octal and hexadecimal. We don't usually write out this line. We're not usually quite so explicit about it. This says you just have to add an extra line to subtract your base before you carry. That's what we're doing here. And we're going to do that quite explicitly for octal and hexadecimal just to keep track of our steps. So I'm using the same two numbers, sort of. That is, I'm using the same digits now that we're going to add an octal, but the two numbers have a subscript of 8, so these are values in octal. Okay, we're going to do the same thing though. Remember that the 6 in octal is in the ones, the 3 is in the 8s, the 4 is in the 64s, 8 to the power of 2. So we're going to line them up the same way. The 4 is in the ones, the 2 is in the 8s, the 7 is in the 64s. And the 1 is in the 8 to the power of 3, or 512. All right, so 436 in octal, plus 1, 7, 2, 4, also in octal. Of course, you can only add two numbers that are in the same system. All right, 6 plus 4 is still 10, but in octal, we can't count past 7. As soon as we hit 8, we move to the next place value. So here we're going to subtract 8. So we have 2 left over, and we carry a 1 over to the next place value. 1 plus 3 plus 2 is still 6. 6 is less than 8, so we get to keep the 6. 4 plus 7 is 11. We can't go above 9. Can't go above 8, I should say. So we're going to subtract 8. That leaves us with 3 in, what is this? This is the 8 to the power of 2. This is the 64's place. And we'll carry the 1 to the 512's place. And we have 2 here. We're allowed to keep 2 because it's less than 8, so we're good to go. So our final octal answer is 2362. Subtracting works the same way. Similarly, we're going to have this extra line where we describe what we're doing. I'm using the same digits once again, 1724 and 436. And when we subtract them, we would, of course, line them up so that the thousands, the hundreds, the tens, and the ones are lined up. So we'll do that here. So 1724 minus 436. I'll give both a subscript of 10. Notice that I'm just using the grid here because it makes it easy for me to line up the values. All right, what happens here? 4 minus 6. Well, 4 minus 6 is negative 2. I can't write in a negative 2, but that just means I need to borrow from the next place value. So if I borrow 1 from the 2, I'm left with a 1 in this place value. If I borrow from the next place value in the decimal system, I'm borrowing an entire 10. Negative 2 plus 10 is 8. Often when we're working in the decimal system, when we borrow a 1, we simply write a little 1 over top of the topmost number, recognizing that this turns it into a 14. Borrowing 1 is borrowing 10, plus 4 is 14, and then subtracting 6. But it's a little bit easier for us when we're working in octal and hexadecimal if we properly add in this line, make it very explicit how much we're borrowing. Because even though we're subtracting 1 from the next column, we're not necessarily adding an entire 10 to the ones column if we're working in a different number system. Let's try this again. In the next column, in the tens, I have 1 minus 3. That's also negative 2. As soon as I'm below 0, I'm going to have to borrow from the next place value. If I borrow from the 7, that turns it into a 6, and I'm adding 10. So I get another 8. All right, 6 minus 4, that one's more straightforward. I have a positive value, so I'm just left with a 2, and 1 minus 0 is still 1. So 1,724 minus 436 in base 10 gives us 1,288. Easy to check that with your calculator. So once again, I recommend that you try 1 or 2 of these. Make up your own values. Try the subtraction with this formal extra line for 10. And that's what's written up here. It says when subtracting, we add the base in the extra line if we have a negative difference and borrow from the next column. So when we had a negative difference like negative 2, in the extra line, we wrote that we borrowed 10 from the 2 in the next column over. We're ready to try this in octal. Use the same digits again. Of course, it's not the same number because it is in a different number system. 1724 minus 436, both in octal. 4 minus 6 is still negative 2, so if we have a negative difference between 4 and 6 is negative 2, we do have to borrow. Borrowing from the 2 still decreases it to a 1, but how much are we borrowing? Well, this is the ones column, 8 to the power of 0. This is the eights column, the eights place value. So we're not borrowing 10 this time, we're borrowing 8. And negative 2 plus 8 is 6. Similarly, in the eights column, which would have been the tens if we were in decimal, 1 minus 3 is negative 2, and with a negative value we have to borrow. Borrowing from a 7 turns the 7 into a 6, and once again, borrowing an 8. And that gives us 6. 6 minus 4 is still positive 2. Anything that's positive we get to keep. 1 minus 0 is still 1. So in this case, our final answer, when we do the difference, is 1266 in octal. All right, working in hexadecimal is only a little bit different because we have to worry about letters. So in fact, the first thing I'm going to write out when I work in hex is the conversion between the letters A to F to their numbers in decimal. A, B, C, D, E, F would be 10. And it is 10 sort of in hex. It represents 10, but these are the decimal values that these represent. Okay, so just so that I've got a handle on that before I dive right in. Once again, I'm going to add up the two numbers so that their place values line up. So we have 3D2A and we're going to add 2, 2, F, F. I hardly need to write that this is hex. As soon as I have a letter, I recognize what's going on here. Okay, let's add these together. So we have to do a little bit of converting either in our heads, or maybe I'll write it down here to make sure we know what's happening when we're trying to add A plus F. Well, A is 10 and F represents 15. So what I'm really doing here is I'm adding 10 plus 15. 10 plus 15 is 25. But of course, I can't go higher than 15. As soon as I hit 15, that's like hitting 9. If I add one more to that, I'm moving over to the next place value. If we were working in decimal, we would have subtracted 10. In octal, we would have subtracted 8. But here, we're taking the 16. So we want to know what value do we have left over in the ones column when we take the 16 and move it to the 16s column. We have 9 left over. Okay. 1 plus 2 plus F. What is F? F is 15. So here we have 18. We can only go to 15. We could only go to F. So for more than that, we're going to have too much. So we're going to subtract 16 and make sure that we carry a 1 into the next place value. 18 minus 16 is 2. So far, I've been able to write down numbers. Of course, if I was left with not a 9 but a 10, I would have written an A. If I was left with an 11, I would have written a B. And here it just so happens that we end up with nice numbers, ones that are a little more familiar. All right, moving on. So this is the 16 squared. It starts to get a little ludicrous quite quickly when we take base 16. But in any case, D is 13, and we carried the 1. Let's not forget about that. So we have 1 plus 13 plus 2 is 16. Can only go as high as 15. We can only go as high as F. So as soon as we hit 16, we're going to carry the 1 over into the next column. But 16 minus 16 is 0. When we've carried all 16 over to the next column and indicated that as a 1, we don't have anything left behind. And lastly, 1 plus 3 plus 2 is 6. So our answer in hex is 6029. And finally, subtracting in hex. I'm using the same values again. 3D, 2A. We're going to subtract 2, 2, F, and F. And those are both in hex. Again, I'll write myself a little cheat sheet. A through F is 10 through 15. Just so I don't have to work too hard and count those out on my fingers every time. And of course, start on the right-hand side. So here we have A minus F. A is 10 still. F is still 15, so it's really 10 minus 15, which would give us a negative 5. We can't have a negative 5 when we subtract. It means we have to borrow 16 from one column over. So from the one column over, the 2 turns into the 1. And normally we'd have borrowed 10 in decimal, and the one we're familiar with. But we're working in hex, so we're going to borrow 16. Negative 5 plus 16 is 11. But we're in hex, so we can't write 11. We have to use B. So negative 5 plus 16 is B. Moving one column to the left, I have 1 minus F. F is 15. So 1 minus 15 is negative 14. As soon as I have a negative value, I'm going to have to borrow from one column to the right. If I borrow from a D, it goes down to a C. How much am I borrowing? Because we're in base 16, I'm borrowing 16, and negative 14 plus 16 is 2. C minus 2, C is 12. I'm subtracting 2. So I get 10. But we don't write 10 In base 16, we write A. And then finally, 3 minus 2 is 1. That's not a problem. We write that down as a 1. So our answer is 1A, 2B. For adding and subtracting in binary, you can use the technique we just covered in adding and subtracting in octal or in hexadecimal. Binary subtraction, however, when it's done by your computer, is done using 1's complement or 2's complement. So we'll have a look at what these techniques actually are. So they follow these steps. Take this first number, the blue number, and subtract the second number. Okay, so our first step is to make sure that both numbers have the same number of digits. Here we have 1, 2, 3, 4, 5, 6, 7 digits in the first number, which means, because we only have 5 digits in the second number, that we'll want to add 2 zeros to the front. 0, 0, 1, 1, 0, 0, 1. Now I'm going to write these down in the grid so I can line them up correctly. I'll write the first number down exactly as it is. So starting on the left, I have 0, 1, 0, 1, 1, 0, and 1. But when I write the second number down, I'm going to write down not the number exactly as written, but I'm going to write its complement. In other words, I'm going to write down what happens to each of these values when you throw them through a NOT gate, which will make more sense if you have a look at Boolean algebra. I'm going to flip each 0 to a 1 and each 1 to a 0. So that second number becomes, reading from left to right, 1, 1, 0, 0, 1, 1, 0. Okay, now we're going to add the complement to the first number. So we'll do an addition here. We do addition starting on the right-hand side. 0 plus 0 is 0. Okay, that's just a 0. 1 plus 1 is 2. But we're working in base 2, so we can only have zeros and ones. So when we hit 2, we're going to subtract 2 and carry the 1 to the next place value. So we're left with 0. 1 plus 1 is 2. Similarly, you're going to have to carry the 1 to the next place value, so we have another 0. 1 plus 1 is 2. We'll have to carry the 1 again. 1 plus 1 is 2, and we'll carry the 1 as we subtract 2, moving through those same steps each time. This one's kind of interesting. We end up with a 3. 1 plus 1 plus 1 is 3. Anything greater, 2 or greater, anything greater than 1, we're going to end up carrying, but we don't have to carry all of it. We only take the 2 and move that to the next place, to the next column. So we're left with a 1. Start again. We're left with a 1. And in this final column, 1 plus 0 is 1. Okay, you'll have to trust me on this. Take the leftmost carry and add it to the result. This is the leftmost carry. So we're going to move it to the ones place and add it to the number we just got. Okay? So we're left with 1, 0, 0, 0, 0, 0, 1. I pretty confidently started adding on the left-hand side here because I looked ahead and saw that 0 plus 1 would be 1, and there wouldn't be anything to carry. That's the final result of the subtraction, the original two numbers, using 1's complement. Let's look at the same subtraction and just use a different technique. This is 2's complement. The first two steps are the same. We want to make sure that we have the same number of digits in both numbers, so we know we need to add 2 additional digits to the second number. And then we're going to write both into the table. So we're, of course, same step here. We're going to flip the second number. We're going to write its complement. 1, 1, 0, 0, 1, 1, 0. And now, right away, I'm going to add 1 to the complement. So I'm going to this number, add 1, which means that the 0 actually turns into a 1. Let me tidy that up. So immediately after I wrote the complement of the number that's being subtracted, I added 1 to it. Okay, now add both numbers together. 0 plus 1 is 1. 1 plus 1 is 2. We can't have a 2, so we end up with a 0 and carry the 1 all the way through. We already know what the answer is, so we know we have a whole pile of zeros in the middle of this number, so this shouldn't be surprising. Right until here, where we end up with 3. We still have to subtract 2, so we've got a carry of 1. 1 left behind, carry of 1 means it's here. And then our very last step is to drop the carry. So our final answer is 1, 0, 0, 0, 0, 0, 1. That's our answer in binary. So practice doing that subtraction using both techniques of 1's complement and 2's complement.